This video will show the basic functionality of the pyNITA program, I think. So as it exists right now. So right now this is in the pyNITA prompt. So that's where it's launched from right now, from the pyNITA run bat. So step one is selecting working directory. I'm going to set it to the demo dataset. So the demo dataset is available on GitHub. Choose a user configuration file, which should populate this area. Step two, you don't have to do, but it's where people test their piecewise fits on point files. So the point files are in the input folder, sample points, and then I should be able to look at what points are available to me and what kind of things they show. And visualize the trajectory. So NITA is just doing the fitting of this piecewise fit. Should be able to show multiple on the same plot. Should be able to stretch this out without these weird axis issues happening. It's another fix for another day. You can also optimize trajectories based on your local knowledge of a particular pixel. So let me show you this. So this pixel actually has a pretty big disturbance in 2015, but the trajectory as parameterized is not showing that. So if we grab couple pixels here, maybe we'll do the first three and hand draw the trajectories. Then I can load a default set of parameters. I'm going to pare this down a little bit just to speed up the runtime. Parallelize this process. Picking up again, you can see that now there's optimized parameters have been selected, and I can save those to my configuration file. And then I can visualize these again. Let's just see if that updated. I think it did. Yes, I believe so. So now you can see that disturbance in 2015 is properly characterized. Okay, so that's how you optimize it. It's kind of play around with the algorithm and set your optimization parameters in step two. And step three is actually running on images. So I'll bring in a image stack, bring in the associated dates with each image. Okay, and you can create a subset if you only want to run on a little bit of the image. So this is the whole image, which still isn't very big, but we'll just draw out a subset for right now. You can run and view a subset results, but you can't save them right now. We'll parallelize this. And So you can see one nice thing about having this logging screen is that it does give you some semblance of a progress bar, and that's something that we'd like to retain or remake in some way or another. So I'll let this run and then start the video again. Oh, it's all done. That was quick. Okay, image metrics created. So now in step 4, you can choose the metrics to look at. So kind of a diagnostic one is just linear error. This is just the error that would come from fitting only a single line to your time series. So this just gives you an idea of where disturbance probably is, where this is high. And then you can check by clicking on these pixels. So if I click on a pixel here, it brings up my actual pyNITA fit, and it shows, yep, there's definitely a disturbance there. So a simple linear fit would not be sufficient. If I go over here, a simple linear fit is much closer to being adequate. Another common output is disturbance date. And you can see here that only a part of the image was actually disturbed and the rest of it probably just wasn't disturbed. Or the algorithm is at least not picking it up. So in this case, oh, it looks like there was a disturbance there, but we may not have set something, a change of this small magnitude to actually equal the disturbance. So we may need to parameterize a little better. That's probably good for now, as far as we can come back to some of these later. So that's basically all it should do, and then ultimately you could run on the whole image and save off these images with georeferencing such that they can be opened up in a GIS program.